We'll be solving this biomechanics problem, which shows the shoulder, elbow, and the hand. So we have two links here, which is from elbow to hand and shoulder to elbow. We are provided with the link length and the length or the distance to the center of mass. We have a hand weight, which is 100 Newton, about 10 kgs. And then we are supposed to compute the external moments and forces. So the way to approach this problem is to solve each of the segments individually. And since this is one rigid body and it's in an equilibrium, what we can do is we can break it down into two different parts at the elbow, and we can assume there are some forces being applied. So F, E, X, F, E, Y. And then we can also assume a moment, E. And I'm going to be assuming this to be our plus X, this to be our plus Y. This is my positive moment. And since it's a rigid body which is stationary, we need to make sure the point where we divide the elbow into parts should be balanced when it's put together. So we need to apply equal and opposite forces. So we'll have Fex, Fey. Also gonna have an opposite moment, E. Okay, now what we can do is we can look at each of the links individually. So for the first one, I'm gonna draw the FBD here again. So we have the elbow, and then we have this hand. We have about 15 Newton load here. We have about 100 Newton load here, and then we have forces Fex, and then Fey, and then E here. And we also similarly we'll also have another link, which is our link from shoulder to the elbow. I'm going to draw that as well. So the shoulder to the elbow, and here we have the weight of this link, which is about 18 Newton, and we know all the lengths. We have some forces here as well, which are these Fex, Fey, and this moment Me. Okay, now we're going to solve each of these links by doing the force and the moment balance, because everything is in static equilibrium. So we'll do the force balance in x direction. So summation of all the forces in x is going to be 0. The only force in x I see here is this thing Fex. So I'll put down Fex, and then it's going to be 0. Similarly, we'll also do force balance in the y direction. So summation of Fy is going to be 0 as well. We have a few forces in the y direction. The first one I see is this Fey. It's in the positive orientation to what we assumed as our coordinate system. And then we have one more force, which is 15 Newton, but this is going to be negative because it's going opposite to what we believe is positive. And similarly, we have the negative 100 Newton force as well. It's going opposite, and it's going to equal to 0. So that's how we get our Fey to be 115 Newton. One more thing that we need to do here is to do the moment balance in order to find the Me. So summation of all the moments is going to be 0, and since this is a planar problem, this is along the z direction if anyone's interested, but we don't really need to care too much about that. So balance all the moments. The first one, Me, is along the positive assumption that we have made. So it's going along the positive. So Me, and then we see that there's going to be a moment through this 15 Newton, and there's going to be a moment through this 100 Newton, which is opposite to what we believe to be positive. So we're going to apply the moments. Moment is basically, since this is perpendicular to the moment, we'll just do the force time the distance. The distance in this case is this thing, which is 0.2 meter. So we're gonna do 0.2, and then we'll have a moment to do the 100 Newton, and this distance is gonna be the whole link length, which is 0.35, and we'll equate it to 0. And if you solve this using a calculator or something, and if you solve this term is gonna be 3, this is gonna be 35. So Me comes about to be 38 Newton meters. This is gonna be Newton. So this is how we solved the first link. So we have Fex, Fey, and we have the Me. And now we're gonna solve the second link. So we have a few of the forces already. We know all the forces in the grain, Fex, Fey, and Me. Now we are gonna assume a different set of forces. So we're gonna assume Fsx, we're gonna assume Fsy, we're gonna assume S. And now we're gonna do the same exact thing for this link. We do the force balance in the x direction. The only force we see is Fsx minus Fex. It's gonna be 0, but this is 0, so basically means our Fsx is also 0. We're gonna balance the forces along the y-axis. So we have the first force, which is Fsy, and then we have the minus 18 Newton. We have minus Fey. I believe these are all the forces that we have here, and this results in basically Fsy. We already know Fey, which is 115, and so we're gonna sum that up. I think this is 133 Newton, and now we're gonna sum all the moments and equate them to 0. So the first moment I see is the ms, which is positive, and then there's gonna be a moment due to the 18 Newton, and this is at a distance of 0.12 meter as given here. So 0.12, and then there's gonna be a moment due to the Fey, so which is again negative, so 115 Fey, and then the distance, which is 0.25, and then we are gonna have additional another moment as well, this Me right here, and it's opposite to our convention, so we are gonna subtract Me as well, which results in Ms or Mse, just Ms, which results in Ms equals to 68.91 Newton meter. Right,